Welcome back to the next video in the solids module. We are looking at cylinders in this video. So I'm going to go ahead and turn to that tab and page over to this particular page. The first thing I need to show you is how to calculate the volume of a cylinder. Okay. And there's a formula to do this. There's a formula for both of these. We're not going to have to do the parsing on this page. We could, but it's going to take a long time. So I'm just going to show you the formula and then we'll solve the problem. But if you look at the cylinder with me, a cylinder is a can. It's like a soup can or a soda can. It's something that holds liquid, usually paint, but it can be solid. The example I'm going to use is of a silo on a farm where you might be storing grain to feed your cattle. So that is a very large cylinder. That's why I like that example. So let's put some dimensions in here. We're not going to count this. This is not to scale. I'm just going to make these up. But the first thing I want you to notice is the radius. Okay, so draw yourself a radius in there. And I'm going to make up a number for radius. We're going to say that it is 12 yards. And a yard is about the length of my arm. It's 3 feet. So this is a very large structure. If you had a silo or even a water tank, that's another good example of a cylinder. Near my house there's a school and there's a big water tank that looks like this that supplies that school. So whatever example you think about, let's say that the radius is 12. And the height of this particular cylinder I'm making up is 15 yards. And while I'm thinking about this, you would always want to be sure that your units match. If you had one in feet and one in yards, you would need to fix that before you proceed. So we have 12 yards and 15 yards. Yards and yards are good. We're good to go. But that's something to bear in mind on a test. The formula to do a cylinder's volume looks like this. V equals pi r squared h. So you have pi, radius, and height. So we have the pieces that we need to solve this problem. And I'm going to bring my formula up here and I'll show you how to do that. Write the formula down. Please, please do not try to do these without writing the formula, because you'll end up using a diameter or a width or something that your formula does not want. So please don't skip that step. This is not the time to be lazy. We don't know volume, but we're about to find out. I know pi never changes, so that's something that I can constantly use. Pi is 3.14. The radius for this problem is 12 and the height is 15. Now you've heard me say in other formulas it doesn't really matter which one you put where. In this one it does. You have to get your radius and your height in the right spaces. So please be careful. Okay, the next thing we need to do is deal with the exponent. So I'm going to go ahead and you can do this on your calculator, but I encourage you to go ahead and work it out. I've seen better results to do that. But 12 times 12 is 144, and then the rest I'm just going to copy down. And then I'm going to pick up my calculator and let the calculator do the work for me. So 3.14 times 144 times 15 equals, and I get 6,782.4. This is volume, so it's cubic yards. When I first started teaching math to adults, we were not allowed to use a calculator. So we had to work all of this out by hand. So things have changed, and I'm glad. So what does this mean? So we've got this number, so what? What is that telling me? It is saying that this particular silo or water tank or whatever it is holds 6,782.4 cubic yards of corn or water, whatever the stuff is. So this is the amount that it will hold if you fill it to capacity. Volume is how much it holds. Okay, at the bottom, I've given you the same cylinder. So let's not change the numbers right now. We're kind of on a roll here. Let's just leave well enough alone and draw in the radius. And that's going to be 12. Remember, I'm not changing the units. And the height was 15. So this time, instead of pouring corn in there, I want to know how much paint it would take to paint this whole silo, including the top and the bottom. So I want to paint down here also. I want to paint the entire silo. And there's a formula for this. In the last problem, I showed you how to parse these and get the answer. But in this one, this is just more than I can do to parse. So here's the formula. I doubt you will ever see this formula again unless you do something that is very heavy in math. But just in case, I want to show you how this works. And this formula is pretty serious. This is not a baby formula. It says that surface area equals 2 times pi times the radius squared plus 2 times pi times radius times height. And we're going to have to fill in these values before we can go any further. So here's what I'm going to do. I'm going to mark this part of the formula in red and this part in green, just to help us keep it straight. So instead of running all this by you so fast and in the same color, I'm going to break it down a little bit clearer. So this one I need to say 2. You know what pi is. And you know what radius is, because I told you over there in the picture, radius is 12, and that's to the second power. So let's go ahead and deal with this part while we're looking at it. This is what we did up above. So 12 times 12 is 144. And then 3.14. And we have 2 of them. We have a top and a bottom. So that's why there are 2. You've got the top circle and the bottom circle. And let's multiply. 2 times 3.14 times 144 equals, and you get 904.32. So that's this part of the formula. That's the harder part. Over here, I have 2 pi, radius, height. So this one I can just type in my calculator. There are no exponents or anything weird. So 2 times pi times 12 times 15. And that came out to be 1130.4. And then this addition sign right there is going to come right down here. And so is SA. So SA equals the red plus the green. So the surface area is 2,034.72 square units. So if I want to paint my silo, I need to buy enough paint to cover this many square units. So the top one, I taught you the formula for how to hold an amount. Area is always about covering. So we're painting on the bottom, and on the top we're filling it up with corn. Those are tough formulas. If you're following those, even if you're not crystal clear on what I'm doing, if you're following me, you should pat yourselves on the back. That is an awesome thing. You've come a long way to be able to do these formulas. Let me go back to the very first formula we did. Just bear with me a second. When we did polygons. Remember, this was the first formula right there that we did. And now we are not doing those anymore. We are into solids. We are into some very complicated math. So be proud. I am proud of you for sticking with me. I'll see you in the next video, and we will look at some other complicated shapes. I believe pyramids are next, so I'll see you soon.